So welcome to this first video, and this first video is DC circuit analysis, and it's part of your linear circuit analysis module that you're doing in second year in the DK740 and the DK843 courses that are available in the Dundalk Institute of Technology. So in this first video, I'm going to look at three circuit diagrams. This is the first circuit diagram here, which contains figure 1 and figure 2. Here's the second circuit diagram that we're going to look at in a second, and it contains figures 3, figures 4 and figures 5. And there's a last circuit diagram called figure 6, and we're going to examine each of these circuit diagrams in turn. What I want you to do, of course, is I want you to draw these circuits up in Proteus. But before we do that, we'll just discuss what each circuit is about and what I'm looking for in each circuit. So let's look at this first circuit now. So in this first circuit, what I've got is I've got 4 resistors, R1, R2, R3 and R4 in series. And I want you to use a DC voltmeter in Proteus to measure the voltage across R1, the voltage across R2 using this voltmeter, the voltage across R3 using this voltmeter, and the voltage across R4 using this voltmeter. So when you press play in Proteus after drawing this circuit diagram, you'll get a reading in volts across the first voltmeter, the second voltmeter, the third voltmeter and the fourth voltmeter. If you look closely here, R1 is 100 ohms, R2 is 220 ohms, R3 is 470 ohms and R4 is 1k ohms, and my power supply is 9 volts. I've redrawn the circuit again, but this time I'm trying to measure the current flowing in the circuit. Now because R1, R2, R3 and R4, or in this case R5, R6, R7 and R8 are all in series, the same current will flow through R5, R6, R7, R8 and back into the battery. Okay, so when I press play here, I have a milliampere, the current flow from the positive end of the power supply through the first milliampere, through R5, through the second milliampere, through R6, through the third milliampere, down through R7, through the fourth milliampere, into R8, back out of R8 through this last milliampere and back to the negative end of the power supply. And the same current reading will appear on all of these 5 different milliammeters. Make sure you've set your ammeters to milliamps when you've done this in Proteus, otherwise you won't get a correct reading. So figure 1 and figure 1, they are the same circuits. What happens in Proteus is you can't use the same labels R1, R2, R3, R4. I can't use them over here in this circuit. They have to be called R5, R6, R7 and R8. And Proteus will do that for us automatically. So when you're drawing the circuit diagram, it's actually the same circuit twice. That's why this is called figure 1 voltage measurements and figure 1 current measurements. This is the simplest possible circuit you could have, I suppose, of 4 resistors in series. Down here in figure 2, I've got 3 resistors in parallel. The first resistor is called R9, the second resistor is called R10, and the third resistor is called R11. So we've got 100 ohms, 220 ohms and 470 ohms connected in parallel to a 5 volt power supply. If I press play when I'm simulating this circuit in Proteus, I'll get a 5 volt reading on that DC voltmeter. So the same voltage is across R9, R10 and R11. If I want to measure the currents flowing in R9, R10, R11, labelled here R12, R13 and R14, what I have to do is put an ammeter here, here and here, and again it's milliamps that we're going to measure it here, so make sure it's set to milliamps. When we press play, we'll get the current flowing down through R12, down through R13 and down through R14. We'll have 3 different currents flowing because we've got 3 different resistor values here. So that is the first circuit diagram that I want you to draw up on design sheet number 1 in your DC analysis simulation. Okay, so I'll close that one now and we'll have a look at our second circuit diagram. So again, this is the second circuit diagram. You're going to place these 4 circuits on a separate design sheet in your Proteus simulation. And what we have in this particular circuit diagram is we have a resistor in series called R15. Then we've got R16 and R17 in parallel with each other. And I want you to measure the DC voltages across R15, R16 and R17. And I want you to measure the DC currents flowing through R18, R19 and R20. And once again, these are the same circuits again. Here's figure 3 measuring voltages, and here's figure 3 measuring currents. When you've got that done, you can draw up this simple voltage divider circuit, and I want you to measure the output voltage across resistor R22. So what we have here is a 12 volt power supply connected across two resistors, and I'm getting an output voltage across that resistor R22, which I want you to measure using a DC voltmeter. Figure 5 is a current divider circuit. What I have is a 200 milliamp DC current flowing into the circuit, and it splits into two parts. We've got a current flowing down through R23, which I'm going to measure using this milliammeter, and I've got a current flowing down through resistor R24, which I'm going to measure using this milliammeter. So the 200 milliamps will split into two different currents, and that's called a current divider circuit. Again, I want you to draw up those 4 circuits in Proteus, save your design, press play, and you'll be able to get your current and voltage readings in Proteus. So that's that one. Let's look at the last circuit that I want you to draw up, and this last circuit is figure 6, and really all it is 4 resistors in series, and I want you to measure the total current flowing down through the 4 resistors, which is used using this milliammeter here. Let me make that a bit bigger, which is using this milliammeter here. And I want you to measure the voltages across R25, R26, R27 and R28, and you get 4 different voltages. If you add these 4 voltages up, this voltage plus this voltage plus this voltage plus this voltage, you should get 10 volts. Again, when you press play, you'll get a reading for the current flowing in the circuit and the 4 voltages across the 4 resistors in the circuit. So really what you've got is you've got 6 figures to draw up on maybe 3 design sheets in Proteus, and I want you to simulate those circuits and just refresh your knowledge of how to measure DC currents and DC voltages in DC circuits in Proteus. Okay, thanks for listening.